Right, so longest increasing subsequence, part 2. This is a sequel to a previous problem, uh, which was longest increasing subsequence, but I don't see any relation between the two. I might be wrong. Anyways, this is a very good problem to strengthen our data sets which are not widely used but still asked in interviews. This one basically says that we are given an array of nums and an integer key. All right, uh, and we need to find the longest subsequence of nums that meets the following requirements. The requirement is the subsequence should be strictly increasing in value, and the second one is the difference between any two adjacent elements is at most k. Right, at most k as in it can be less than k or it can be equal to k but can't be greater than k. And we need to return the longest subsequence that meets this requirement, right? So this basically subsequence are, this can be a subsequence 41458 can be a subsequence, right? Any element which are in order, we can also skip elements, but they should be in order. That is a subsequence. For this, as an example, let me take the pen out. So if I take this example, 42143, let's see, take this here, 42143 458 15. All right. So right now, if we try to solve this mentally, what are we given? What 4? Can we take 2 as a subsequence as its next element? No, we can't. Can we take 1? No, we can't because it's not increasing, right? It should be strictly increasing. So we can take only anything that is after 4, right? But there also we have a limit because we are given k. So after 4, what can be the possible element range? It can be 5 or it can be 4 plus 3, 7. Or it can be 6, right? In between anything, 5 to 7 inclusive should be the next element after 4 for a valid subsequence, right? So after 4, straight away I can see just here I have a 5, right? And after that, this is a subsequence, this is a subsequence. After 5, 8 is also valid subsequence because 5 plus 3 is equal to 8. That's fine. So right now I can see 3 subsequence starting from 4. Okay. For 2, let's see the same thing. For 2, the next possible values are 3 or 5. 3 to, sorry, yeah, 3 to 5. Correct. After 2, I see only, I see a couple of values which are valid. For 4 here, this is a valid subsequence as its next element. This is a valid next element. Right? What should we choose? We have a choice here. We have to choose the maximum vote of whatever possible values we find after this. Right? So we are getting something here. Right? We are fixing a number and we are trying to find the next element which is in the range this. That is n plus 1 if this is n plus 1 and n plus 2. This is the range that we are looking for after this. And in this range, we are trying to find the maximum. The maximum one, which will give the maximum subsequence element. So if 4 gives me the maximum subsequence, I'll take that. If 3 gives me, then I'll take that. Right? And after that, I don't see any other. We have another 4, but we have already taken 4 here. So whatever subsequence of 4 is here, the same will be here because because it can't be equal. So whatever is valid after this will be valid after this for this one. So for all 4s, there will be 3 as the maximum subsequence, right? So for 3, what will be the maximum subsequence? Will be uh, 5. Sorry, 4 is also valid subsequence, 5 is a valid subsequence, 8 is a valid subsequence. So 4 in total, right? We are going to see how we are going to calculate that, but just mentally trying to solve it for the first time, we see that 4 is the maximum subsequence that this element gives. Alright, so among all these, I will take 4 for 2. Similarly, for 1, if I see, I will take, so for 1, what is a valid one? I can take 2. What is the range? 2 plus 2, 2, 1 plus 3. That is 4. So this is the valid range. After 1, we see a couple of valid values, but we take 3 because it comes in the range and it gives me the maximum subsequence. So this will be 4. Sorry, this will be 5 because it itself also is giving 1 length, right? And the 4 comes from 3 as its length. So 4 plus 1 is 5. So we see that we have a range and we are trying to find the maximum along that range. This reminds us of a data structure which is called segment trees, right? And that's what we are going to use in this example. Let's see it in a whiteboard. But first, let me take the example again. We'll do a dry run and understand how we are going to use segment trees. K is equal to 3, right? So, so we see if we start from here, right? We start from here, we need values from the right side, right? So in that case, we should start from the right side so that we can have the base condition right here. For 15, 1 is the valid subsequence because there is no other values after 15. We would want 16 to 15 plus k, 18 as the range after 15, but we see that there is nothing. So we have just 15 as a length. This is the maximum that we can get. Right? So we can have a segmental which will take, which will have range, right? Segment tree has ranges. It has what 0 to 50. We can have that. We can calculate and construct this segment tree. We can calculate the maximum out of the given array, and we can use that to construct our initial segment tree like this. We can divide it. I'm not going to show that. There's no space for that, but we can understand it. Here, if we have half of the values, here we have other half. Similarly, this goes on. Actually, I should take. I mean, I can also take the maximum plus k. I can also take that. At the end, I will have I'll have something like the 0, 0. I'll have something like 1, 1. This goes on for all the indexes. I'll have 14, 14. I'll have 15, 15. I'll have 16, 16. But let me show for 15, 15. What's that? This there. This is 15, 15. This is 16, 16. Right here, after creating this initial segment tree before we start traversing, we see that 15, 15. We see that we need a value, right? Initially, we need a value what subsequence it can give us. We can have -1 as the initial value, or we can also have 1 as the initial value. But rather, I'll take -1 because we have a couple of ranges which are not even present in the example. 7 is not present, 16 is not present, 0 is not present. Right? For those cases, we should not get a value of 1, right? That's why I'm taking -1 for all the values, whether it is present in the array or not. This is the initial construction of segment tree. After that, I encounter 15. Like I encounter 15 and I see that I want to update the segment tree with the value 1. Why 1? Because I query the segment tree, I get -1 as the maximum value. Like these will be -1 initially. So I will get the query of -1. I mean, I'll query the segment tree and I get -1 for 15. So I'll take 1 because -1 is not valid. I take 1 as the answer. I'll update for 15, 15 inside the segment tree. Instead of -1, this will be updated to 1. Alright, this will be updated to 1. That is, this also will be updated to 1 then. And this will also be updated to 1. Because that's how it goes, right? For segment tree, if we update the leaf node, then all the above nodes also need to be updated. That's all. So among 0, 7, and 8, 15, among 1 and -1, we get 1 as the maximum value, maximum subsequence. Now we do the same thing for 8. We do the same thing for 5. We do the same thing for 4. For example, for 4, or actually for 8, because for 4 I have to create more nodes for the segment tree to make it, to explain it. But that's why I'll take 8. Right, 15 is being updated. For 8, I'll have 8 here. I will update, that will also be 1, right? So it's not going to change the above values anyways. Let's see for 5 then. For 5, 5 is somewhere here. Right now its value is -1. I see for 5, my range to check would be what? 6. So if I forgot to tell you about 8, Before updating the value, I'm going to query it, right? I'm querying with what range? With 9 to 8 plus k, that is 11. This is the value I'm querying, and I'll query it like 9, 9, 10, 10, 11, 11. Out of these, see what will be the maximum, and then that goes on and on and on till I get the answer, until I traverse it to the top, and I get the maximum, and I return. Uh, that will be what? Minus 1 for 8, because the values for 9, 9, for 10, 10, for 11, 11, it's minus 1. The answer will be minus 1. Maximum of 3 minus 1 is minus 1. So I update for 8 to 1, because 8 itself also is a valid subsequence. So now 1, this will become 1, this will become 1. Similarly for 5, I'll query now. For 5, I'll query what 6 to 8, n plus 1 to n plus 8. I see that I encounter 8 here, right? So 6 to 8, 6, 6 is minus 1, 7, 7 is minus 1, 8, 8 is 1. This will give me 1 as the answer. And 5 itself needs to be added to the subsequence. So 1 plus 1 will be 2. This will be 2. This was 1. This was 1. This goes on and on and on. And at the end, we take the maximum among what values we get here. So let's see in code how we are going to solve it. We are going to have a segmenting. Segmenting. Let me make the values also public. The first, what all values we have generally in a segmenting. I'm not going to use a vector form. I'm going to use a pointer form for creating the segmenting. First member will be the index. The second value will be, the next two values will be the pointer to the next, the left and the right one, or the right, left and the right child. And I'm going to have a maximum value. I'm going to have a constructor. In the constructor, I'm going to pass the left index, which I'll call left I, and right I, and the value as well. Alright, that will help me to update or initialize the member values. This will be right side, this will be right index, this will be left. Sorry, these are already initialized. Should initialize it again. Left will be null, right will be null. The value will be whatever I'm passing it here. We should call it value instead of max value. But this is my constructor. Yeah. Next, I have a construct function which will construct me the segment. I'll pass the left index. I'll pass a vector basically, but instead I'm only going to construct the segment tree with -1 values. So instead of passing the vector, I'll pass the indices like this, and the value. That will be -1. When I'm calling, I'll pass -1. Alright, if the left, uh, let's see, yeah, if the left index is currently equal to the right index, then return a new segment tree with the left index, the right index, and the value. Alright, here I create a segment tree, which I'll call it root. I will have the left index member initialized to left type. Similarly, the right index initialized to right type. So, yeah, and the root left. For that, I need to find the middle index. Where index plus right index by 2. I'm doing this because I think the left and the right index is not going to overflow, so this form is fine. Otherwise, I would have gone like left index plus right index minus left index by 2, something like that, right? Uh, root L is going to be a construct of left I comma mid index, but I should call it mid I instead. This is better. Here I'm passing value again. Instead, I can just pass -1 here. So why do that? Because I'm going to call construct only once. Right? I mean, the recursion is going to call it again and again, but I'm going to call it from the main function only once. So that's fine. Uh, yeah, that's good. This is, I don't need that. Root right will be construct of right I, sorry, mid I plus 1, comma, right. And finally, the root value, max value will be max of root left max value and max root right max value. Finally, we are done with the construction of the segment tree. Pass the root. Alright. Now I will have the update method as well. So I have a void. I will have update. I will have a segment tree passed to it. I can also use that form like this is a member function, right? So this object is going to have a reference to segment tree, but still I'm going to pass it here just to make things understandable. We're not studying roots here, we're studying data and algorithms. So root I'm passing, I'm updating the value, so I'll have to pass the index, I'll have to pass the value. Alright. So if the root left index is equal to index and the root right index is equal to index, in that case I should update the value of the max value to value and return. Alright. There's another base case where no, actually this is good. Now I need to update the uh, since I'm starting from root, I'm going down, I'm diverting. That's why I need the mid index. Mid I is equal to root left index plus root right index by 2. That's something like this. I like to have places here. Now I'm updating the value, right? So I need to call if the index falls in the left region. That is I'm going to check it like left root left index if it's greater than or actually index is less than equal to mid I should call the left part of the segmenting because the root left index and value. Alright. Else it lies on the next right half. We call the root r index and value. Now I'm going to since I'm updating right, I need to update the uh, I mean I went down and now I'm coming back right and backtracking. I need to update the parent values as well. That will be like just equal to max of root left or the second copy here going to be the same thing and everything. So this is our update function. Here we are going to do now query. For query I'm again passing the segment tree. I'm passing the left index because I'm passing the range right in which I'm querying. So I'll pass the left index or I'll call it left type and right type. Here I'm going to call so I'm querying right. My base condition will be something like, let's see, base condition will be, since we are querying, we will go down, we'll come back. For that, I'll check with this left index is equal to root right index, and at the bottom, this is what will to happen. Basically, this is the same thing. Sorry, my bad, this should not be root of right index. I'm checking the left index, right? So this is also I'm going to update as I do the recursion. Right? So this will be eventually equal to right index. And here I'm going to return the max value of the root. Max value. But we also should check for cases where left index might be greater than the right index. Because if you try to do a try run, even on this example, you will find scenarios where left index is going to be equal to greater than the right index. So in that case, you should return -1. Return -1 is valid in that scenario. I will calculate the mid index. That will be root right left index plus root. I can copy that from here. This is my mid index. Here, I will check if the mid index lies included. I mean, if left eye and the right eye is including mid index, then I'm going to have to traverse or query both the left child and the right child, right? So in that case, my check will be something like left eye is less than equal to mid index, and mid index is less than equal to right. And this time I'll have a variable answer that will be 0 initially, and that this answer will take the maximum of query of left child and query of right child. This will be root right, comma, left index, uh, left I plus until mid index, and here it will be root, sorry, this will be left, this will be root right, comma, mid index plus 1, comma, right I, and if else if the left index, if it's greater than the mid index, in that case, uh, it lies on the right child, so I'm going to only query the right child and take the maximum of answer, or the query of right child r comma left index comma right index. Else, I'm going to query the left child. Left child. Alright. So is this an extra phrase? I think it is. Let me check the phrase first. This one is fine. 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 Yeah, I think this is the class. Alright. Here I'm returning answer. So now I have query, I have update, I have construct, I have constructor, I have symmetry, I have everything. I will have a answer here as well, which will take the maximum, and I'll traverse on the reverse direction. So I is equal to 9. But before that, I will have a segment be constructed. Segment is star root is equal to root construct. Uh, Actually, let me take this out of the function, because otherwise it will say that I'm using a null pointer to call the constructor. Yes. Did I not copy it? Yeah. All right. This is my function. Here I will call it like this. Construct right eye, left eye. That will be a variable called max number, which will be usually 0 times the array once and get the max number out. I'll pass the left index will be 0 or rather 1 minus 1. You can have extra values, that's not way to change the answer. And num plus k, comma. Yeah, that's it. If you construct takes two parameters. I have the segment tree ready. We don't use this. Here I'm going to take this minus 1, I is greater than equal to 0 by minus minus. I'm going to post query, right? Answer is equal to max of answer, comma, query of whatever value I have at hand. I pass the root first, left index and the right index, the range, right? Will be nums of I. Let me take that variable outside, otherwise it will be confusing. This will be n plus 1, comma, n plus k, and this should have a 1 added to it because every number is going to have at least 1, right? It's going to have at least 1. That's why I pass 1 instead of 0. Let me see, I think there's some mistake here. Because for 15, I'm going to have the answer as minus 1. Let me take the values here, value of the query plus 1 and take so some, because query might return minus 1 and I want 1 always as the maximum minimum value that I can take. Right? This will be like 1. Alright, this should solve a problem. I'll have answer updated during every query, and I'll update the root tree as well with the index as I and another index, and nums or n will be passed here and the value. Alright, return answer. Let's see if this works. There has to be some problem. This was a long code. Let me source this. Where is it? I'm sure I have R here, right? With L, and that there should be semicolons. Am I using R somewhere? Yeah. And that's a bit. I should change this to semicolon. Let's see now. Right, I query problem is wrong somewhere. Oh, sorry. Root reference. See now. My bad. Okay. This should be left index equal to left I Right hand works right hand, which is fine. I think I should create a segment here. First, right hand, minus one for now. Let's see, segment 3. Maybe this now. Line 31. Oh, this check is wrong because I should check it right. Left I instead. Now let's see. Yeah, this work. Let's try and submit it. Yeah, it works, and time complexity wise, it will be somewhere I think of n log n because we are doing the query and update in within the traversal. So I think of n log n will be the time complexity as well as the space. I think the space complexity will be of n, right? Yeah, probably more than n because we are storing all the values which irrespective of if it is present in the array or not. All right, thanks.